Okay, so good morning. Welcome to GenAI Masterclass, and this is the session 8. So, in this particular session, we will be going to have discussion on to the basics of GenAI. So far, what we have seen from our previous sessions perspective, like we have gone through with the generative AI. Stuff that is like the basic aspects of the generative AI. Then we have seen like what are the different phases, and then what are the different types of tasks that we can perform with the help of large language model or the generative AI basically. And some of the tasks, say, let me try to highlight those particular things for you. Say, if you are able to recall, we have seen, say, sentiment analysis. Then we have seen, say, translations related task and all. And we have seen the different things, say, mask related stuff, summarization, question and answer. These particular things we have seen in our, because previous sessions. But apart from these particular tasks what we have performed so far, there are a lot of things. And probably I have mentioned these particular things over here. You fill mask and all these are the things what we have done. uh, there are other tasks as well, and what I will do, I will share the list of those particular tasks. And if you are if you want to see the different task and all, let me try to get the details. Okay, so over here inside the Hugging Face, or we can ask over here as well, the different categories of tasks that I can perform with LLMs. For example, sentiment analysis, summarization. So it will list down the different tasks that we can do. So with the help of generative AI. It is taking a little bit time. And even like what we can see over here inside the huggingface.co, we can check this particular stuff. Okay, so just have a look over here. Like we will be having the different tasks. You can see over here. Question answering, zero shot classification, translation, summarization, feature extraction, fill mask. Okay, sentence similarity, text ranking, text generation. These are, you can say, natural language processing tasks. Audio tasks like text to speech, text to audio. A lot of tasks are there. If you are able to see, say, audio text to text, image text to text, okay, image text to image. A lot of tasks are there, and for these particular tasks, what we are having the different types of large language models, and those particular large language models are utilized in order to perform these particular tasks. We have seen some of them, say, sentiment analysis and all. We have seen probabilities mentioned over here inside the NLP. Mm-hmm. So we have seen question answering, we have seen summarization, text generation, feature extraction. Probably we have seen. Then fill mask, yeah, translation we have seen. So question answering we have seen. So a lot of tasks are there. What I want to give you an idea basically, uh, so based upon our requirement we can perform a lot of things with the help of these large language models, or especially with the help of generative AI. And these different tasks are covered by different large language model. It is not like, say, one LLM can can perform those particular things. Let me try to show you something else as well. Say platform .openai.com, and I just need to log in. And this balance is pending. API keys. I just need to go to the usage. I just need to check for the pricing of these large language models. The UI has been changed. Audio, image, codecs, API key uses, logs, batch storage, settings. Okay, so now UI, they have changed the UI a little bit. So over here, if you are able to see the recommended models, so GPT 5.5, 5.4, Gemini 5.4 mini, and image, functional calling, web search, file search, MCP. A lot of things are there over here if you are able to see. Uh, I just want to check for the pricing. Price. They have changed the UI a little bit. Pricing. Now we are able to see. Okay, so just have a look over here. Uh, what I want to show, I don't want to show you the price of these particular models, but just try to have a look over here. 1 million token, and these are categorized and under the flagship models. Now, if we are moving down, we are having multi-model models, and the price is also mentioned for, say, for 1 million token, say GPT real time 2 audio, and for 1 million token is $32. Then we are having image generation models. Then we are having video generation models, transcription models. Okay, and then different tools are there. Then certain embedding tools will be there. Fine tuning models are there. So for fine tuning, this is the price, and all models. I just want to see the text embedding models as well. GPT, image, real time, standard batch, flexibility, fine tuning, embeddings, embedding guide, tokenizer, model index. Just have a look over here. Text embedding three large, text embedding three small, and text embedding ADA 002. Okay. Uh, what I am planning to share over here, like there are the different types of models, different models to perform different tasks. And can you tell me why I need to have different models to perform different tasks? Can you tell me? Mm-hmm. Why I need to have different models to perform different tasks?
Because they carry different data, like different large language data.
Hmm?
Because they carry different specific data types, we can say.
Okay, so let me ask it in a different way. If a model uh, is trained on video data, will it be going to provide you the output on image data?
Uh, I think video and image, I think somehow it can provide, but not like others, like audio, or like some other data, like the banking or some other data. They can't
Okay,
provide.
okay. So there are different things. Say capturing audio from a video, okay, capturing audio from an audio, capturing image from a video. All of these are the different things. If you and all of these are working into the different ways, the functionality and performance, a lot of things came into the picture, and all of these are working into the different, you can say, directions. These are working All of these are having their different, you can say, working scenarios, and because of that only, like, we are able to see over here, say, image generation models, okay, you just provide a text and the image will be generated, and there are the possibilities, say you just want to extract the text from an image. It might be possible that uh, the text is given as an image, you can say barcode and all, the number plate of your vehicles, uh, that is an image, okay, and that is carrying the text as well, OCR and all, probably you have here optical character readers. Okay, those particular things are there to extract the textual information from the images that you have captured. And for those particular tasks, we are having specialized model. Say image generation model is there, then transcription models are there. Then we are having say video generation and all. Probably you will see over here somewhere. Uh, you can take it over here. Okay, so real time and audio models. Okay, GPT real time whisper, GPT real time 1.5. Okay, image models are there. Correct. So different categories are there, and these particular models are going to perform the different tasks. The functionality, pricing, each and everything is different, because they are trained onto that kind of data. It is not like, say, I'm having LLM, I'm having a large language model which is trained onto the textual data, and it will be able to generate image for me. No, it will not be the case. Correct.
Yes, sir.
Previously, if you have seen, the chat GPT was not able to generate images and all, correct, it was not able to generate. Are you able to recall? Probably you have seen it, or you have used the chat GPT in order to generate the image, or if you are trying to generate an audio from chat GPT, it will say you need to use different model. Let me try to ask uh, over here. If I'm asking, uh, say, can you generate a new audio song for me? Mhm. So clear that one. Let's see. So it is generating the text information only. I want to have MP4 file for this. Just have a look. I can't directly generate or send MP4 audio or video file in this chat. Uh, Go to Suno.ai, YouTube, and choose custom song and lyrics and all. Then you will be able to generate and download. So what did you get over here? Probably the model which is being utilized over here is not capable to perform this particular task. Hmm? Is it? Are you able to?
Okay. Yes, yes, sir.
Okay. So what I want to say, we are having different large language models, and these large language models are going to perform different tasks. A classification, category is classification and example task. You can do sentiment, intent, spam detection, extraction, NER, key value. So we can perform a lot of tasks with the help of the large language models what we are having. Some of them we have performed, and I will share you a list, and you just need to use that particular task. You just need to mention, say, inside the pipe. You need to import the pipeline from transformer, use pipeline, and then mention the task. It will download the default model. In this particular way, the method will remain the same. Okay, over here, what I have done, like the pipeline is a sentiment analysis, and then I'm just providing a particular review. Say I watch a movie and I don't like it at all, so it is providing me a review. Say this is the negative review, or the sentiment is negative over here. So I will share the list. Over here you are just mentioning the sentiment analysis. Say then you just need to change that particular task. Say the next task, say question answer is there, so you will be able to ask the question answer. Now what I will do, I will share the list, and you just need to use that particular task and try to perform the different tasks. Okay, you need to do it by yourself, and that is quite easy. You will be able to do that. Uh, you will be having these particular notebook files to help you out over there, and just try to proceed with those particular remaining tasks, and you will be able to get a lot of information. Okay, so that is one thing, that is one aspect what I want to cover in session 8. Say different models to perform the different tasks, and there is a category, and I will share that particular list. Over here this is not the complete one. I will share the complete list. Now, moving further, what is being happening internally? Yeah? Say, if you are mentioning, say, you are providing certain inputs to Chat GPT. Yeah. What is? Can you tell me something about, say, generative AI? Yeah. Okay, you are having this particular query, and you went to ChatGPT, and you are asking ChatGPT this particular question, and it is going to use certain LLMs and all, and it will then provide the output. Output. This is a normal flow. Okay, and like how the things are happening in the GenAI world. You are going to, this is an application basically what is given by the OpenAI. So this is an application, Chat GPT, and it is going to utilize certain large language models. Okay, uh, and then we will be able to get the output. But what exactly is being happening internally, that we'll try to decode that particular piece in today's session. So over here, first thing is, say, tokenization. Now, whatever you are going to mention over here, the the computer or the machines are not able to understand this particular thing. So how the computer will be able to understand it? So what we need to do, we just need to convert it into the tokens format. Tokens, it means we just need to convert it into the numerical format, and numericals are known to computer. So what we will do, we will do tokenization. Tokenization. So tokenization is something like converting the you can say, the information or converting the words, the word or character into numerical data. Okay, so that is nothing but tokenization. Now I have mentioned three things over here: a word, subword, and character. So tokenization is possible at the three levels: word level, subword level, and then character level. Character level. Now, word level tokenization, it means each word will have a token. Okay, so if I can say this is my sentence, okay, this is the sentence, and I will split it into the words and say uh, over here, say can is have say one token, two, then three, then say four, then five. Okay, can you tell me something about generative AI? AI is good. Okay, so six, seven, say eight, and then nine, and then nine, then 10, and say 10, and then say 11. Okay, um, so for the understanding perspective, like I have just mentioned the sequence, but it is not like that. So AI is used twice over here, and both of these two AI is having the same token. So AI over here, the token ID is 9, and in the same fashion like AI used over here as well, so the token ID is 9. So what I mean to say over here, like each word will have its own token. So these particular things are there. So you can see these are the tokens. Now what I can do the tokenization based upon the subword level as well. It might be possible, say over here something is there. I'm taking this and is an this something as an example. So something is, say, something can be divided into two parts, and it can be, say, some and thing, and then somehow, somewhere, okay, somewhat. Okay. It can have like the different combination as well, somehow, somewhat, although like these are the you can say different words. So what I can have, like if I'm mentioning it in this particular way, this something will have say one token, and all of these sums will have the another token, say two. Don't, I just don't want to. So say this sum will have, say, token ID, say 12. So same will happen with this, same will happen with this. But this something in cumulatively will have the another token ID. So what researcher has observed, like we can split the characters in such a way that the total number of required tokens uh, can be, you can say, decreased. So because of that particular angle, the subword tokenization scheme has been evolved, and then it is giving some better performance related stuff as well. So what I can say, one word can have different tokens. One word can have one word can be splitted into two or more words, and then each subword will have different token. Okay, and let me try to show you something with the help of this, say, platform dot openai.com. I just want to show you the tokenizer only. So I'm opening the tokenizer information directly. So show example. So over here, many words map to one token, but some don't. Indivisible Unicode characters like emojis may split. So it has given one example. And just have a look over here. Uh, it has given say total 53 tokens and 252 characters are there. And this is based upon say GPT 5.x O1 oblique 3. Okay, based upon this particular tokenization scheme. And like we are having different mechanisms or different algorithms in order to have the tokenization. So tick token is widely used tokenizer scheme, and that is going to perform the tokenization based upon the subword level. Tick token, that is tokenizer. A library is there, that is going to perform the tokenization. So let me read it a little bit. Learn about this tokens, common sequence of characters, and you can use. And let me try to go learn more. And what I want to show, they have given one example, and based upon this particular example, it is having 53 tokens. If I'm going to change the model, so I'm just using GPT-4, and say what about GPT-4? It is having say 57 tokens. The characters are same. GPT-3 legacy. What about this? It is having say 64 tokens, and then it is having 252 characters. And if just have a look over here, how the tokenization is being working over here. So many is say one token, words is another, map to one token, but some don't have. So don't, DON, and uh, comma T. So both of these are having separate tokens. IND, I is having one token, IV is another one, and Isabel is the another token. You can the color is denoting the different tokens basically over here. UNI, IC, and ODE. This is the different token. If I'm going to change the model, say GPT-5x. So just have a look. Unicode is the single token at this moment. Okay, indivisible previously this was having the three different tokens. Now it is having two tokens only. Okay, so subword, although like the subword tokenization scheme is being utilized, this is these are the tokens basically, dividing the sentence into say words. That is the tokenization, and we are having token IDs as well. So 12488, so and 63914014, these are nothing but the token IDs. Okay, so and if I am going to type something, say, let me copy and paste our example over here. Okay, and let me paste it over here. Okay, and so it is saying, say, oh, sorry. It is saying, say, 15 tokens and 59 characters are there. And just have a look how the tokenization is being working over here. So what I have mentioned, subword tokenization scheme is being utilized. Can you tell me something about generative AI? Yeah. So generative GENER So these are having two different tokens because we have used the subword tokenization scheme over here. AI and AI. Yeah. So all of these are having say different tokens, and if I'm going to say check the token ID, and you will be able to see say 13 and 13. This is denoting probably the ID for AI. Yeah, so for AI we are having the 13 ID, and we are able to see over here. So you can take it in this particular way. AI is good, and also you will be able to see it over here. Uh-huh. Okay, so what did you get from this tokenization?
So sir, same mean to say in the one sentence, same word like will have same token ID. Is it right
Yes,
or like?
yes, same word will have same token ID. Just have a look.
But in
Uh,
the yes, here you are saying the AI and AI is same 30 number. But if you see the order, it is different, like something, na?
just a minute. Let me try to good, good, good. Okay, so you will be able to get the information.
I think same. I think there's space they have used 198 something, na? I think
Uh,
space or
uh, uh, uh.
the written thing.
So 198 is probably for I think
Next line or space
next line for this 30744.
and
Okay,
190,
and then
198 for
for,
good.
yep. For one new liner 30744,
Okay,
and
sir.
198 is for good. Correct.
Yes, sir. But like the order is not same for AI. If you see the AI 13, that only I think the dot is there after between the both the AI.
Probably it
But
might be
here,
because of the space and all.
okay, sir. Okay.
Mm-hmm. Correct.
Hmm.
Okay, so over here, what I want to say, like the computer or the digital machines are not able to understand what you have mentioned over here. So what we have, what we need to do, we need to convert it somewhere like that can be understood by the computer. So what we are going to have, what we just need to convert it into the tokenization and all, and tokenization is digital representation of this particular data. Correct. So we are going to convert it, and uh, basically it is going to improve the process as well. How it is going to improve the process or performance basically. So whenever say AI is there, it will be able to point to say this particular token. And with respect to AI, say it is say having the number 9. Although like where in the platform.openai we have seen say the token ID was I think 13 for this. So for the for example perspective, I just mentioned say 9. So AI is having 9, so it will be stored once somewhere, and whenever AI is there, we just need to fetch that information 9, and then it will be able to work. So it will be it is called as and when we are having that particular information. So or that tokenization is working. So that information is called from that particular storage, and then it will be utilized. You can say pointer related stuff is there. Value is there, key is there, and we are fetching the value, and that value is being utilized in the in the subsequent processes and all. Okay. So it is of three types: word level, subword level, and character level. Now, what is the meaning of this character level tokenization? It means, say, if I'm having CAN, so it will have three tokens. Can say 1, 2, 3. Okay, 1, 2, 3. Okay, C will have its own token, A will have its own token, and N will have its own token. Okay, now what will happen to the vocabulary? Yeah. Okay, vocabulary. Yeah. Now, what is being happening if, just give me a minute. इसमें बात करना ये कार चेक करने के लिए आया। Okay, so vocabulary, yeah. Vocabulary is say total words or tokens used in a particular large language model. Okay, so if I'm using character level tokenization, what will be the vocab size? If I'm using character level tokenization, what will be the vocab size? How many characters are there in English language? Guys, are you able to understand what I'm trying to say? What is vocabulary? Yeah.
It's a different words, like collection of words.
Vocabulary is a collection of words. And if I'm saying say total vocabulary means total words in a particular
Mm.
model. Okay. Or total words, or in another way, tokens. Okay. Now, if I'm using character level tokenization scheme, in English, I'm having 26 characters only. English, I'm having 26 characters only. So whatever I'm going to mention, it will be mapped in 26 characters only.
Okay, you mean to alphabets? You are referring to alphabets?
Alphabets.
Okay.
Okay. So once I'm using character level tokenization, the vocab size is 26 only.
Okay.
Correct? But if I'm using word level and subword level tokenization, it is, you can say, different for each and every model. And let me try to, can you tell me the vocab size for different LLMs? So just have a look over here. GPT-3 over here, like BPE tokenization scheme is utilized, and it is having 5257, 50,257 total tokens. If I, whatever you are going to mention, so whatever you are going to type over here, it will be from these 5257 tokens only. Okay. It includes the new line character, comma, space, and all. Each and everything will be included into 50,257. Now, if GPT-4, it is having a lot of tokens, almost say 1 lakh tokens are there. And if Llama 2, it is having say 32,000 tokens inside its vocabulary. Yeah. Llama 3 is having 1,28,000, and say Palm 2 is having 2,56,000. This is, you can say, bigger one. Gamma 2 is having 256K tokens, or the words basically inside its vocabulary. Yeah. What is the meaning of this? What is the meaning of this? If I'm saying say 50,257 are the total words, and the model which is having say 256K. So what is the meaning? What is the difference between both of these two? What are you able to get?
Vocabulary size is different. Like one, the previous one has like 50,000 approx words in that vocabulary, and the next one has 256K number of words. So that's right.
Come again?
Like I'm to say the number of words or vocabulary size is different, na, in both.
But
The
different. That this is fine. The difference is there among the size. But what this difference will do?
there are more chances to get the correct output in the lateral one, like the which have 256K vocabulary size, because
Which is
our
having more, you can say, vocab
more
size.
vocabulary has there are chances that we will get our data, like our.
You can take it in this particular way. The LLM, which is having say more vocab size, so it is trained onto the uh, different data, or it is having say more
Okay.
training information and all. It is
Okay.
able to differentiate among the different things. Say if we are having mathematical or symbol or scientific symbols as well, it is able to understand those particular symbols as well. Probably it is not there in say GPT-2 or GPT-3. Or if we are especially talking of say Mistral large language models, which is having say 32K vocab size. So somehow, like, if it is not trained on that kind of data, so it will not be able to provide that particular information. Correct. So
Mhm.
vocab size is also playing a critical role with respect to the model understanding and all. Okay. Uh, I will not say this 257 5257 vocab size is less and it will not be able to provide the correct information. But it will be able to provide the information based upon the specific trained specific data on what it is trained. Okay, say I'm sitting in one organization and I'm having limited amount of data. I have trained the LLM based upon that data, and I'm asking the queries based upon my organization data only, and on top of that data only, the LLM was trained. So it will be able to provide, if I'm looking for the information which is information from the large language model, apart from the knowledge on top of what it is not trained, it will not be able to provide. So those particular things are playing a critical role. Some of them are going to enhance the scope of large language model, like it can do scientific calculations and all. And for scientific calculations, we used to treat different symbol as a separate token. We can't, you can say, club that token into the we can't club it with another, you can say, word. Correct. So if we are having such information, the scope of the large language model will be increased. Correct. and it will provide more accurate information.
Okay, sir.
Okay, so the main motto, what was the intent over here? Say LLMs are not able to understand what you are mentioning, okay, in a plain English. Although like we can say LLMs are able to understand it, but what exactly is being happening? Things are tokenized, and then tokens are given to the subsequent processes, and then uh, the functionality is being happening onto those particular tokens, and then we will be able to get the information. Okay, so first one is the tokenization. Now after tokenization, the transformers came into the picture. No? Okay. So after this, these are the tokens and all. Oh, sorry, vocab size and all. Vocab size. What is vocab size? If I ask in one liner,
Number of words in that particular LLM that used to train like
number of words or tokens in a particular LLM. No?
LLM. Yes.
Okay, so that is the vocab size. Now, basically, I'm going to start the transformer architecture. No?
Sir, this tokenizer like it is different like types of tokenization mechanism, right? Sentence piece, new tokenizer, sentence word
Uh-huh.
piece.
So, like these are, you can say, different algorithms with the help of what we are going to perform the tokenization now.
Okay, okay,
But the base will remain same: word, subword, and character. This
okay,
is
sir.
the base approach. You can split based upon the way word, you can split based upon subword, and you can split upon the character. Character, like it is limiting the performance, and like tokens are less, but limiting the performance and all. Over here, word level tokenization. Okay, so we'll have a token for each and every word, and for subword level, we'll have less number of tokens basically. Yeah, say over here, say for some, and say someone has mentioned say something. Okay, and for something, show thing, something. So say something is there, but I'm having a token for some as well. I'm having a token for thing as well. So there is no need to generate a new token for this particular something. I can have say 11 and say 12. I'm mentioning hypothetically. So it will not be say new token for is say 13. It will be 11. I will split it and into this particular way, and 12. There is no need to have generation of new token based upon uh, a given word. Correct. So somehow I will be able to limit it, and I will be able to have less number of tokens, and it is the most widely used pattern, subword level tokenization. And these, you can say, tokenizers, take token, sentence piece, word piece, BP, I think band pass encoder. So these are working, but all of these are having the base subword level tokenization schema. These are working onto the subword level tokenizations. Okay, so once the tokenization is done, the next piece what is coming into the picture, that is transformer architecture. You know, like once if we are talking about the transformers, this is, you can say, the base of large language model. Okay. Uh, GenAI is possible, new content generation is possible because of the transformer architecture only. Okay. And what is transformer architecture? This is the combination of attention and MLP, yeah, multi-layer perception. This is nothing but feed forward neural network. Network. So what I will do, I will uh, I will start the transformer architecture from tomorrow's session, and that is, you can say, very important, and it is, you can say, it is the heart of generative AI, and you need to pay attention in order to understand it. We'll we'll spend some time over here inside on top of the transformer architecture. We'll be moving with some mathematical calculations and all, which will guide you, like how the things are happening internally, and what are the different, you can say, functions internally that you need to learn. So we'll go through with those particular functions in detail during this transformer architecture. And this is very important. If you are like planning to learn generative AI, you need to go through with transformer architecture. It is mandatory. And if it is clear, then you will be able to, you can say, decode generative AI. So that is very important stuff. You just need to pay attention during the sessions, and you can ask if you are having any doubt, but this is a mandatory, you can say, piece that you need to cover. Okay. So I think that's all for this particular session, and tomorrow, like what I mentioned, we'll start with transformer architecture, which is having two main pieces, say attention and MLP. Let me take a pause over here, stop the recording, and ask if you are having any doubt.